It is tempting to smile and shrug off the efforts of well-meaning young politicians. But the wave of ignorance that is being driven by the well-intentioned is growing larger each day and is threatening to bias the decisions of governments throughout the world. I would like to ask Miss Chloe Swarbrick a few questions before providing her with some basic climate change facts. Do you know that 500 scientists wrote a letter to the UN in September 2019 saying there is no climate emergency? Do you know that carbon dioxide once formed more than 80% of the Earth's atmosphere? Do you know that those levels have fallen until today, where carbon dioxide is now just a trace gas, forming just 0.041% of the atmosphere? Do you know that during a relatively recent period, covering 6,000 years, carbon dioxide levels naturally increased while global average temperature decreased? If you do not know such basic climate change facts, how do you judge such statements as this, or this, or this? Please devote a few minutes of your time to complete this video and study some climate change quite basic facts. It will provide you with valuable information devoid of any emotion. Information about climate change comes at us from all directions. It is difficult to fit together all the pieces to form a coherent point of view. And we can be sure that ignorance of basic climate change facts will give us a warped perspective, while a sound knowledge of some basic climate change facts will provide an alternative perspective. With that in mind, this video will construct a climate change toolkit of some quite fundamental facts. These facts will help us gain a better perspective of statements such as these. The last 30 years were likely the warmest 30-year period of the last 1400 years. The tiny percentage of carbon dioxide in the atmosphere has big consequences. 2018 was warmer than the average temperature between 1951 and 1980. The warmest 10 years since records began in 1850. Warmer at the Earth's surface than any preceding decade since 1850. Constructing the toolkit will examine each of those statements and put them into perspective. Its target audience is the ordinary person. But it may be of great help to the media and politicians and Hollywood intellectuals and climate protesters. The toolkit may help them better understand what it is they are protesting about. The construction of the Climate Change Toolkit will be broken down into two sections. We will put basic climate change facts into the toolkit that will allow us to gain an objective perspective on statements such as those from the IPCC and media quoted earlier. Having established the fundamental toolkit, we will then build on that foundation. To help us in our task, we will employ this chart of global average temperature from 1850 to 2018. The data source HADCRUT-4 is the only source dating back to 1850. Other sources, such as GISS and NASA, start from 1880 but are aligned to HADCRUT-4. We will build up entries in the chart as we proceed. For our understanding, HADCRUT-4 uses the temperature anomaly baseline of 1961 to 1990, which by definition has a temperature anomaly of 0. For neatness, we mark that baseline simply like this going forward. To build the first item in the toolkit, we will deconstruct this statement. We will return to the headline later, but for now we'll focus on the text. It says that 2018 was 1.5 degrees Fahrenheit, 0.83 degrees Celsius, warmer than the average temperature between 1951 and 1980. There is an immediate point of order. Is the statement a case of comparing apples to pears, where the apple is an average and the pear is a single year? For our present purpose, this is a distraction, so we move on. And to get a perspective on this statement, we will focus on the period 1951 to 1980, which is the reference point of the comparison. Now, the average temperature anomaly for 1951 to 1980 was 0.05 degrees Celsius. This translates to an actual global average temperature of around 14 degrees Celsius. Now, this happens to be just about the same global average temperature as existed 2.58 million years ago at the start of the Quaternary Ice Age. At that time, much of the USA and Canada was covered in thick ice sheets, as was Greenland, Great Britain, Scandinavia, and large parts of Northern Europe. It is natural to wonder why then the present ice sheets are not as large if the global temperature is the same. The short answer is that the climate is much more complex than that. But in this case, there is a quite straightforward answer. For tens of millions of years prior to the Quaternary, the ice sheets had been extending as the global temperatures dropped. So that at the start of the Quaternary, they were much larger than today, even though the global temperature stood at approximately 14.1 degrees Celsius. We thus have our first entry into the toolkit. The mid-20th century global average temperature of 1951 to 1980 was approximately the same as it was 2.58 million years ago at the start of the Quaternary Ice Age. Now, that fact may not have shocked you, But just wait, there is much more to come. The perception of relative temperature and what can be regarded as normal is fundamental to our understanding of climate change and will play an important role in building the toolkit. We left off at the period 1951 to 1980. This is an approximate midpoint between the two periods, 1900 to 1909 and 2009 to 2018. The temperature anomaly of 2009 to 2018 was plus 0.59 degrees Celsius relative to the period 1961 to 1990. The temperature anomaly of 1900 to 1909 was minus 0.40 degrees Celsius. A sensationalist headline might proclaim that global temperature has increased by 0.99 degrees Celsius since 1900 to 1909. And from one perspective, this is correct. But knowledge of basic climate change facts will provide another perspective. In a study that reconstructed regional and global temperature for the past 11,300 years, it was found that the decadal mean global temperature of 1900 to 1909 was cooler than greater than 95% of the Holocene. Applying this to our chart, we see that the decadal mean global temperature of 1900 to 1909 was cooler than greater than 95% of the past 11,300 years. And when comparing this period to 1951 to 1980, we can conclude that the global average temperature of 1900 to 1909 was 0.45 degrees Celsius cooler than at the start of the Quaternary Ice Age. We can combine these two findings into our toolkit as one fact. We will now focus on the year 1850. It is the reference point of comparison for this statement and this statement. As a preamble, we can note that when measuring something, it is vital to have a fixed and relevant start point. A start point that is variable or not relevant introduces problems. So, what is the start point used to measure global warming? The IPCC bases its measurement relevant to the start point of, quote, pre-industrial levels. And it uses the period 1850 to 1900 as its equivalent. 1850 to 1900 thus becomes the reference point for global warming comparisons, as in these two statements. Let's put the IPCC reference or start point into perspective. This is the chart we have developed so far. We now add in the reference period 1850 to 1900. The global average temperature for that period is minus 0.31 degrees Celsius, which means that the mean global temperature of 1850 to 1900 was approximately 0.36 degrees Celsius cooler than at the start of the Quaternary Ice Age. Therefore, the IPCC start point for the measurement of global warming, 1850 to 1900, was approximately 0.36 degrees Celsius cooler than at the start of the Quaternary Ice Age. Not only should this shock you, it should give you an entirely different perspective on statements such as this and this. We put climate change fact number 3 into the toolkit, and then we will ponder just what does this fact mean? What are its implications? The implications involve the concept of measurement referred to earlier, and the concept of what it is to be regarded as normal. I will use myself as an example. If a nurse takes my temperature and he or she tells me that my temperature is 2 degrees higher than the reference point of 37 degrees Celsius, then I know I have a problem, because the reference point of 37 degrees Celsius is regarded as a normal temperature for human beings. Similarly, if I am told that my temperature is 2 degrees lower than the normal reference point, then I know I have a problem. But if I am told that my temperature is 2 degrees higher than a reference point of 35 degrees Celsius, then I conclude that I do not have a problem, as my temperature is in fact quite normal. This is because the start reference point is low and could not be regarded as normal. It is thus not relevant to any discussion about the normality of my temperature. Applying the same logic, what does that say about the reference point of 1850 to 1900? Can it be regarded as normal? What is its relevance? The answers to both questions can be regarded as judgments as opposed to facts. So nothing extra goes into the toolkit at this point. But we will add a few more items to the foundation, each of which will raise eyebrows. This chart from a reconstruction of regional and global temperatures for the past 11,300 years shows temperature anomalies relative to the same 1961 to 1990 reference period used by Hadcret 4. Global average temperature rose at the end of the last glacial period and the beginning of the present Holocene period. There followed, for thousands of years, a period where global temperatures were well above the 1961 to 1990 reference period. The warmth created a golden period in human history, starting with the Neolithic Revolution. And for a 2,000-year period, the global mean annual temperatures around 8,000 to 6,000 years ago were about 0.7 degrees Celsius higher, and extratropical northern hemisphere temperatures were about 1 degree Celsius higher than for pre-industrial conditions, that is 1850 to 1900. That fact must go straight into the toolkit. Following thousands of years of warmth, temperatures gradually dropped. This drop culminated in the coolest temperatures of the entire Holocene period during the Little Ice Age, which was around 1450 to 1850. To obtain another item for the toolkit, we now need to focus on this time period. It approximates to the 2000 years preceding 1850. As can be seen, this entire period was cooler than at least the 7,000 years of the Holocene, from around 8600 BCE to 1600 CE. This fact becomes toolkit item number 5. But from the same data, we can conclude that the reference period 1961 to 1990 was also cooler than at least 7,000 years of the Holocene. This fact enters the toolkit with the thought that many people watching this video will have lived through the cool period of 1961 to 1990. Others will have been born during that period or shortly after. Makes you think. Anyway, we have nearly constructed the promised foundation of climate change facts. These facts will allow you to view the following IPCC statements from a new perspective. The last 1400 years were cooler than at least 7,000 years of the Holocene. So were the past 800 years. And to the period 1200 to 1899 and 1400. Having raised eyebrows, we can finish the foundation with a missing subject: carbon dioxide. At the beginning of this video, we saw the headline that as at 2019, a low carbon dioxide makes up only 0.041% of the Earth's atmosphere. This tiny percentage has big consequences. Very briefly, we will shine some light on that statement. We return to our chart of global average anomalies from around 9350 BCE to around 1860 CE. We will compare it to this chart of carbon dioxide levels over roughly the same period. They are almost mirror images. And there is a large time span when they go in opposite directions. As you can see, the period covers around 6,000 years. Carbon dioxide levels rose from 258 parts per million to 282 parts per million. However, over the same period, the global average temperature anomaly dropped from plus 0.41 degrees Celsius to minus 0.20 degrees Celsius. So another fact goes into the toolkit. For around 6,000 years, carbon dioxide levels naturally rose from 258 parts per million to 282 parts per million, while global average temperature dropped from an anomaly of 0.41 degrees Celsius to an anomaly of minus 0.20 degrees Celsius with respect to 1961 to 1990. What accounts for this behaviour? It could be that there was only a trace of carbon dioxide in the atmosphere. After all, it was only 0.0282%. But even in 2019, carbon dioxide is a trace gas, making up only 0.041% of the atmosphere. Perhaps it was because carbon dioxide has a very low global warming potential of just 1, while other gases are between 1,000 to 10,000 times stronger. Or, to paraphrase Noah, maybe the causal link between carbon dioxide and the climate remains exceedingly difficult to determine. With that thought, we have reached the end of section 1. Future videos will add more items to the toolkit. Section 2 now builds on the foundation of section 1 by examining a question posed by Noah. Human activities are estimated by the IPCC to have caused approximately 1 degree Celsius of global warming above pre-industrial levels, where the term pre-industrial levels refers to the period 1850 to 1900. This raises the spectre that something very unusual is happening. However, the climate is always changing, so it is very pertinent for Noah to ask, just how unusual are modern temperatures compared to those of the past? To answer that question, we need to examine reconstructions of past climate changes. This video does just that, in order to find out how unusual are modern temperatures compared to those of the past. We do this in 4 stages and summarize at the end. Stage 1 will take us from 540 million years ago to the inception of the Quaternary Ice Age, approximately 2.6 million years ago. To give perspective to what follows, it is useful to know that the mid-20th century global average temperature, that's 1951 to 1980, was approximately 14 degrees Celsius, 57 degrees Fahrenheit, and the 1989 to 2018 global average temperature was approximately 14.5 degrees Celsius, 58 degrees Fahrenheit. At 540 million years ago, the time of the Cambrian explosion, the global average temperature stood at approximately 26 degrees Celsius. The landmass of the Earth was, of course, very different to the continents of today. But as we go through the journey, you will see how movements of the tectonic plates eventually formed the continents we know today. Using slides from the PaleoMap project, we are able to track the changes to the climate that did occur from 540 million years ago up until the start of the Quaternary Ice Age. Global temperatures remained high for some time, but a sharp drop took place with the formation of the Andean-Saharan Ice Age. At one point, global temperatures were as low as 14 degrees Celsius. Global temperatures fluctuated again until the Karoo Ice Age. During the Karoo Ice Age, the global average temperature twice fell to 13 degrees Celsius. The ice lasted for around 100 million years. Then a long period of higher temperatures set in, covering nearly 200 million years. The climate zones became very simple, and it is just possible to see the outline of the modern continents taking shape under the control of the tectonic plates. At around 50 million years ago, a long-term cooling trend set in. Arriving at the mid-Pliocene 3.3 million years ago, the continents and ocean basins had nearly reached their present geographic configuration. While mean global temperatures were around 1.9 to 3.6 degrees Celsius higher than pre-industrial levels. Our early human ancestors were also around at this time, and temperatures continued to drop. So that by around 2.58 million years ago, the present Quaternary Ice Age became firmly established. The inception of the present Ice Age set in motion cycles of climate change that influence the climate to this day. We will follow these events up to the start of the Holocene. Over the previous 50 million years, a long-term cooling trend had taken place, with changes in the climate occurring in irregular cycles. As the world cooled, these cycles transitioned to more regular cycles. The start of the Quaternary saw the inception of alternating warm and cool periods that took place with a recurrence period of around 40,000 years. This period coincides with the Milankovitch period of obliquity, which sees the Earth's axial tilt move over a similar period. These regular cycles persisted for 1.8 million years. At the end of that time, the cycles changed during what is known as the mid-Pliocene transition. This transition saw the onset of modern climate change cycles. These cycles coincide with the Milankovitch cycle of eccentricity, where the Earth's orbit around the Sun changes from nearly circular to more elliptical over a period of around 100,000 years. From that time until now, these cycles initiate alternations between cold glacial periods and warmer interglacial periods. The essential features of these alternations is reflected in the definition of glacials and interglacials. This recognizes that interglacials, such as the Holocene, in which we now live, are incompatible with the wide extent of glaciers that characterizes a glaciation. So for the past 800,000 years, the Earth has seen alternating cold glacial periods with ice on the northern hemisphere continents, and warmer interglacial periods with little or no northern hemisphere continental ice. Significant swings in GMST were quite normal during both glacial and interglacial periods. As these cycles proceeded, a marked interaction between modern humans and climate change took place around 200,000 years ago, during an interglacial period. This saw humans adapt to the warmer climate and disperse northwards and eastwards out of Africa. We now move to the last 130,000 years of glacial interglacial cycles and the Eemian interglacial. This was the last interglacial period prior to the present Holocene and lasted about 13,000 years. During the Eemian, the global mean annual surface temperature is estimated to have been approximately 1 degree Celsius to 2 degrees Celsius warmer than pre-industrial. High latitude surface temperatures, averaged over several thousand years, was at least 2 degrees Celsius warmer than present. At around 128,000 years ago, East Antarctic ice cores record early peak temperatures of approximately 5 degrees Celsius above the present. There were also large GMST increases, with warming of more than 10 degrees Celsius as compared to late Holocene. But eventually the inevitable climate change cycles kicked in, and another approximately 100,000 year glacial period saw the ice sheets extend and sea levels drop. Humans that had migrated from Africa into Europe would have faced a fight for survival. Ice sheets covered northern Europe and Scandinavia. Most of the rest of northern Europe resembled semi-desert with a mixture of tundra and grassland elements. Even in southern Europe, conditions were poor, with vegetation resembling a semi-desert and just scattered pockets of trees in some moist areas. This fight for survival may have contributed to the extinction of the Neanderthals. In Africa itself, the Sahara was larger than it is today and was hyper-arid. The approaching end of the glacial was signalled by the last glacial maximum, somewhere between 21 and 18,000 years ago, when the ice sheets reached their greatest extent. The termination of previous glacials had seen a sharp rise in global average temperatures. This pattern was repeated with a sharp rise in GMST now. But at around 12.85 thousand years ago, the Younger Dryas event occurred. The previous sharp rise seemed to indicate the end of the glaciation, but this turned out to be a false dawn. For temperatures plunged again. Then, after around 800 years of lowered GMST, another sharp rise saw the final climb to the Holocene interglacial. This warming phase at the end of the Younger Dryas was very abrupt, and central Greenland temperatures increased by 7 degrees Celsius or more in just a few decades. Having arrived at the Holocene, we will rely for the next stage, up to 1850 CE, on this study. This covers the past 11,300 years, using proxy data from 73 globally distributed records. Global temperatures rose steadily at the onset of the Holocene, producing complex climate changes. Few things demonstrate the enormous complexity of climate change than the transformation of the hyper-arid Sahara. rather than the increased temperature further drying out the soil, instead humidity increased and tropical summer rains transformed the Eastern Sahara. It became habitable and prehistoric humans started to settle there. As the temperatures increased, so did the fertility of the Eastern Sahara, and so did human occupation. Over the following thousands of years, human settlements became well established throughout the Eastern Sahara and saw the introduction of domestic livestock, which included sheep and goats. The increased global temperatures thus enabled the Eastern Sahara to join the Neolithic or agricultural revolution taking place in other regions, especially the Middle Eastern Fertile Crescent. This period saw the transition of humans from small nomadic bands of hunter-gatherers to larger agricultural settlements, leading to early civilization. From around 8,000 to 6,000 years ago, the IPCC reports that the global mean annual temperatures were about 0.7 degrees Celsius higher, and extratropical northern hemisphere temperatures were about 1 degree Celsius higher than for pre-industrial conditions. As global temperatures dropped from its peak, so did the humidity, and some parts of the Sahara began to dry. This triggered the movement of human populations to unaffected regions and a migration into the Sudanese Sahara. After thousands of years of warm temperatures, the full benefits of the Neolithic revolution became manifest with the emergence of true civilizations across the globe. There began a period of over 2,000 years when the global temperatures dropped. This brought to an end the humid Saharan conditions at around 1,500 BCE, and the Sahara began to return to the state we know today. Civilizations still flourished, however, and in fact, the movement of populations away from the Eastern Sahara towards the Nile Valley strengthened the growing Egyptian civilization. The pyramids of Giza were constructed during this time. The Shang Dynasty in China came to prominence shortly afterwards. The decrease in global temperature continued. In fact, the last 2,300 years have been the coldest of the entire Holocene. The resulting climate change may have contributed to the collapse of the Maya civilization. Temperatures continued to drop until we reached the period 1450 to 1850, known as the Little Ice Age. This saw the coldest period of the last 2,300 years and the entire Holocene. Icebergs became common off Norway. Ice fairs were sometimes held on the frozen River Thames, and advancing mountain glaciers crushed entire villages in the Alps. The end of the Little Ice Age brings us to the end of this stage. We now track global mean surface temperatures from 1850 to 2018. We can track the global mean surface temperature from 1850 onwards using modern recording methods. We are using the Hadcrat-4 dataset for this purpose. At 1850, the temperature anomaly relative to the 1961 to 1990 average stood at minus 0.373 degrees Celsius. Temperatures first dropped but then rose, so that by 1878 the GMST anomaly was plus 0.035. Over the next more than 30 years, temperatures dropped, so that by 1911 the GMST anomaly was minus 0.544 degrees Celsius. This was followed by a rise to 1944, where the anomaly was plus 0.144 degrees Celsius. For nearly 40 years, the trend was mostly downward, but in 1981, the approximately same level as 1944 was recorded. By 2018, the temperature anomaly had increased to plus 0.595 degrees Celsius, and in doing so, had recorded a peak in 2016 of 0.797 degrees Celsius. We can now compare modern temperatures to those of the past. First is the IPCC reference period 1850 to 1900 that is used to approximate pre-industrial GMST. This has a temperature anomaly compared to the 1961 to 1990 average of minus 0.312 degrees Celsius. Comparing that to the previous Holocene era, it can be seen that the IPCC reference period is cooler than around 95% of the entire Holocene. Before making further comparisons, caution needs to be exercised when comparing periods prior to 1850 with subsequent intervals. For whereas the modern climate record is regularly recorded and provides monthly and annual measured data, the data of the Holocene is reconstructed from 73 proxy records. They have sampling resolutions ranging from 20 to 500 years, with a median resolution of 120 years. This tends to mean that temperature changes over smaller periods often get smoothed out. However, a meaningful comparison is possible with periods of around 120 years. This interval of 120 years is quite convenient, as it approximates to the modern post-industrial period of 1901 to 2018. The temperature anomaly for this period is plus 0.005 degrees Celsius. When we compare that to the rest of the Holocene, we find that the average temperature of the 20th and 21st centuries is cooler than much of the previous Holocene. In fact, it is cooler than a period of approximately 8,000 years. Exercising caution, we can now reduce the interval used to represent modern temperatures to a 50-year period, 1969 to 2018. This period has a temperature anomaly of plus 0.259 degrees Celsius. Using that as the comparison, we still find that it is cooler than much of the Holocene. Being more specific, the period covered is approximately 5,500 years. This means that the modern global mean temperature for 1969 to 2018 is cooler than the global average temperature of a period covering approximately 5,500 years. We began with statements from the IPCC. To bring this analysis to a conclusion, we will now examine two further IPCC statements. This statement, that warming of the climate system is unequivocal, and since the 1950s, many of the changes are unprecedented over decades to millennia, serves very well. In the first instance, how meaningful is a comparison to decades to millennia, when we have seen that the past 2 millennia were the coolest of the entire Holocene? Leaving that aside, we can focus on changes since the 1950s. This had a temperature anomaly of 0.131 degrees Celsius. This is the comparison to the Holocene. 1950 to 2013 was cooler than 7,000 years of the Holocene. But let's bring the period right up to date to 2018. The temperature anomaly is now 0.17 degrees Celsius. This extended period shows that the modern global average temperature since the 1950s is cooler than the global average temperature of a period covering 6,500 years of the Holocene. Moving to the next IPCC statement. It says that the period from 1983 to 2012 was very likely the warmest 30-year period of the last 800 years in the Northern Hemisphere, and likely to be the warmest 30-year period of the last 1400 years. Not wishing to be tedious, but the relevance of these comparisons to 800 and 1400 years ago must again be questioned. Now, the period selected by the IPCC starts from that point in the 20th century, when global temperatures started to rise again after an almost 40-year pause. The temperature anomaly for that period was 0.318 degrees Celsius. Now, extending the period up to date to 2018, the anomaly is 0.374. We now map this to the Holocene. The intersection covers a period of 5,000 years where the global average temperature was warmer. However, this is perhaps a little fuzzy, so we will select a more clear-cut conclusion. This intersection is quite clear. It shows that the modern global average temperature for 1983 to 2018 is cooler than the global average temperature of a period covering approximately 1,000 years of the Holocene. We can now reflect on our journey through the reconstructions of past climates. When reconstructing pre-Holocene climate changes, we saw that the present Quaternary Ice Age is the coolest of the past 270 million years. The modern pre-industrial climate was cooler than the mid-Pliocene by up to 3.6 degrees Celsius. The modern pre-industrial temperature is estimated to be cooler than the Eocene by up to 2 degrees Celsius. And at high latitudes, the present surface temperature is cooler than the Eocene by at least 2 degrees Celsius. Reconstructing the Holocene, we found that modern pre-industrial conditions were cooler by about 0.7 degrees Celsius than the conditions from 8 to 6,000 years ago, and extratropical northern hemisphere temperatures were cooler by about 1 degree Celsius than the same period. The IPCC pre-industrial reference period of 1850 to 1900 is cooler than nearly all of the Holocene. The global average temperature of the 20th and 21st centuries is cooler than a period covering around 8,000 years of the Holocene. The most recent 50-year period of 1969 to 2018 is cooler than a period covering around 5,500 years of the Holocene. We saw from looking at IPCC statements that, with no apologies for mentioning this again, the reference period of 1850 to 1900, from which global warming is measured, is cooler than almost all of the Holocene. The GMST since the 1950s is cooler than a period of the Holocene covering around 6,500 years. The most recent period of 1983 to 2018 is cooler than a period of the Holocene covering around 1,000 years. So we reach our conclusions. When examining all reconstructions, two conclusions rise to the surface. We are currently living in a climate that is cooler than the beneficial climate that existed for much of the present Holocene, during which the Neolithic revolution occurred and modern civilizations developed. So, when compared to the past, modern temperatures are not unusual.